So atomic physics MCQs, question number 37. The notation of an isotope of sodium is 11 and 23. Which row gives a composition of a neutral atom? So how many protons are there? As you can see, the nucleon number A is equals to 23 and Z is equals to 11. So how many protons are there? Number of proton is given by Z, 11. Number of neutron is equals to A minus Z. So in this example, it will be 23 minus 11, which is equals to 12. And number of electron, it's a neutral atom. So number of proton and electron will be same. So it will be 11, 12, 11. So A should be the right answer. For question 38, the radioactive isotope of a hydrogen undergo a beta decay. To form beta decay, the radioactive isotope of a hydrogen undergo a beta decay to the isotope of helium. What is the nuclide notation of a hydrogen? So it undergo a beta decay. So in a beta decay, if an atom undergo a beta decay, atomic mass remain the same and atomic number increases by 1. Like if this particle undergo a beta decay, then what should be the product? The product atomic mass does not change, it remains same, but atomic number increases by 1. So this should be the result. If this undergo a beta decay, atomic mass does not change and atomic number increases by 1. And if this undergo a beta decay, atomic mass does not change and atomic number increases by 1. So, and if this undergo a beta decay, even this is wrong, the symbol, because 2 proton is not hydrogen, 2 proton is helium. It should be helium. So if helium undergo a beta decay, atomic mass does not change and atomic number increases by 1. So the question is, this is a product form. So which atom will form this product? So it means whenever hydrogen 3 and 1 is there, because when H3 and 1, it undergo a beta decay, atomic mass remains same, atomic number increases by 1 and produces helium, and there's a beta particle, which is 0 and minus 1. So that's why C is the right answer for this. When measuring the emission from radioactive rocks, which are brought into the lab, like example, there are radioactive rocks which are emitting out harmful radiation such as alpha, beta, and gamma, and we bring them inside the lab. A teacher mentioned that the background radiation must be taken in account. Like we should measure the radiation from the surrounding. So rock here in this example, rocks are representing the source. We should take a background radiation. What is the background radiation? Background radiation are infrared radiation from warm object. That is wrong. Infrared radiation from sun, that is because background radiations are also ionizing radiations such as alpha, beta, and gamma. So ionizing radiation from radioactive rocks, which are, but rocks are the source here. They are not the surrounding, there's a source. So we don't call that as the background radiation or radiation from them as a background radiation, because we are determining the emission from the radioactive rocks. So rocks are the source for us. Anything other than the source is known as a surrounding. So you ionizing radiation in a lab when the rocks are not present, that are called a background radiation. Like example, if this lab was empty, like without any these radioactive rocks, so the radiation which are coming into this lab from the surrounding, what we call that radiation, we call them as a background radiation. So D is the right answer for this. Then in question 40, we have a solid cesium which is 137 decay by emitting a beta particle to form a solid barium 137 which emit gamma. Barium undergo no further decay. The half-life of the cesium is 33 years. We have a block which is cesium 137, which is having a mass of 2 microgram. The diagram shows a radiation detector, a distance 5 centimeter from a block. The detector registered the count 2000. So basically there are 2000 counts or 2000 radiations. So if we have, the question is which statement is not correct? Look, if we have a 2 microgram, if we have 2 microgram of a radioactive sample after the half-life of after 33 years, half-life is a time taken by half of the sample to decay. So after 33 years, out of 2 microgram, 1 microgram will be stable, does not emit out radiation, and 1 microgram will be unstable. But the total mass does not change. Like total mass, if originally the total mass is 2 microgram, final the total mass will be 2 microgram. But the only difference, first all 2 microgram was unstable, all was emitting out radiation. But after half-life, the one which is stable does not emit out radiation, and the one which is unstable will emit out radiation. But the total mass, if it was 2 microgram at the beginning of experiment, that will remain same as after the half-life. The only difference, amount from this 2 microgram, if originally all was radioactive, but after half-life, half will be radioactive and half will be non-radioactive. So the question is, which statement is not correct? After 33 years, the mass of a block is 1 microgram. That is wrong. Why it is wrong? As I mentioned, the total mass will remain same. The only difference is amount of the radioactive and amount of non-radioactive will change, but the total mass will remain same. If we check the second option, A is the right, A is the basically statement is not correct. So A is the answer for this. Why not B? They're saying after 66 years, a sample contained 1.2 or 1.5 microgram of barium. That is true. Like example, first, we have cesium, 2 microgram of cesium is there. After half-life, after 33 years, out of 2 microgram, 1 microgram will be cesium and 1 microgram will be barium. And barium does not decay. After further half-life, after another 33 years, because half-life is 33 years, so after another 33 years, 0.5 microgram will be cesium and 0.5 microgram will be barium. So it means total 66 years, because 33 years here and 33 years here, so total 66 years. So after 66 years, how much barium will be there? 1 microgram and 0.5 microgram. So 1 plus 0.5, so that is 1.5. So this statement is correct, or this statement is true. When we check option C, with 5 centimeter of a lead between them, so if you place a lead, it's emitting out beta, the radiation, the count rate will be just above the background, or it will be background. That is also true, because lead can stop alpha, beta, and gamma. That's why there will be no radiation. And if 2 millimeter of aluminum is there, the count rate reduced significantly. That's also true, because beta particle can be stopped by aluminum, so the radiations are not able to pass through. So the detector counts will decrease as well. So statement D, C, and B all are correct. A is not the right statement. The total mass does not change, it remains same, but out of total mass, amount of cesium and the barium will change. Amount of cesium, as it decays, decreases, and amount of barium, it increases. So in this question, what are the isotopes of element? What is the definition of isotope? Because they are atoms of the same element, which are having same number of proton but different number of neutron. That is the definition of isotope. So C will be the right answer. Then in question 39, a radioactive isotope carbon-14 is there, which decay by emitting out beta. So if there's a carbon-14 and it emit out beta, turn into nitrogen, and beta particle is there. So what happened? We know atomic mass does not change. There is no change. If it was 14 before, it will be 14. But atomic number increases by 1. So here no change. Here it increases by 1. So if this is 7 here, what should be the number? This should be 6. So X should be 6. And what about this number here, the charge on the beta, that is -1. So this is -1. So Y is -1 and X is 6. So X is 6 and Y is -1. So it matches with option A. Beta particle is a fast moving electron. Which statement explain how beta particle are emitted from an atom? Look, source of the radiation is the nucleus. All these particles are emitted out from the nucleus, alpha, beta, and gamma. What happened in alpha decay or alpha emission? Atomic number and atomic mass changes, but in beta, there's no change in atomic mass, only atomic number changes, and gamma. But what is the source of all the radiation? The nucleus. Nucleus contain neutron and proton. Nucleus emitted out alpha particle, which is 2 proton and 2 neutron. Nucleus emit out electron, which is a beta, and nucleus is emitting out energy, that's gamma. So source of all the radiation, alpha, beta, and gamma, is the nucleus. So beta particle is a fast moving electron. Which statement explain how beta particles are emitted from the atom? So an electron is emitted as a beta from inner electron shells. No, that's not from the shell, that is from the nucleus. Outer electron shell, that's also no. Emitted from the nucleus, so either C can be an answer or D. But what happened in emission of a beta emission? The neutron actually break down into proton and electron. One of the neutron breaks into proton and electron. Proton remain inside and that electron goes out. That is actually an emission of beta particle. So neutron changes to proton and a beta or electron emitted from the nucleus. So C is the right answer for this. So in question 38, Rutherford bombarded a thin gold foil with an alpha particle and he found some of the alpha particles were deflected at a large angle. So what is the reason why some of the alpha particles are deflected at the large angle? Most of the atom consists of empty space. If most part of the atom is empty space, alpha particle passes straight. But in the question they're saying that why some of the alpha particle deflected at a large angle. So this is a right statement, but not explaining a deflection. All the positive charge and the most of the mass of atom are concentrated in the small volume. That's true. Like nucleus contain a charged particle. So alpha particle are also charged, so they are deviated or either they will bounce back. So there is a mass and the charge in the nucleus. That's why alpha particles are deviated at a large angle. So B is the right answer. Why not C? Positive charge in the gold atom is spread evenly throughout. That is wrong. That is because the positive charge is only present inside the nucleus. All the negative charge is concentrated at the center. That is also wrong. In the atom, we have center, neutron and proton, and around electrons are there. So statement B is correct, which shows that there's a positive charge and the mass which is present in the center. That's caused a deviation of alpha particle to large angles. The diagram shows a path of alpha. So alpha is positively charged, so it is deflected towards negative. Beta is negative charge, so where it will go? It will go up. So what happened to beta particle as they are entering the same electric field? So alpha particle moved down, so beta particle, because unlike charges attract and like charges repel, so as a result, they will deflect upward. Alpha is positive where beta is negative as it is a fast moving electrons. Then the graph shows how the count from a radioactive source changes over a period. What is the half-life? How to work out the half-life? Half-life means time taken by half of the sample to decay. We can take any value. Example, I took the first value, which is 2000. So what is half of 2000? So when the counts are 2000, how much is the time interval? What is the time? You can see that is the beginning, 0. When the count is 1000, half of 2000 is 1000. So how much time it took? The time, so half of 2000 is 1000. So 1000 is after 1 hour. So what is the time interval? The time interval is 1 hour. And this time, radioactive sample to take half of its original value, we call that as a half-life. But it is not necessary that you take first value, like the highest value, you can take any value. Example, another student take 1000. So when it is 1000, you will find the time, that is 1 hour. So when the radiations are 1000, the time is 1 hour. What is half of 1500? So when we work out the time from 500, it will be 2 hours. So 500 is after 2 hours. So what is the time interval when it becomes half of its original value? So that is 1 hour, because when 1000 radiation, the time was 1 hour. When 2000 radiation, 500 radiation, the time is 2 hours. So the time interval is called a half-life. So it took about 1 hour to be half of its original value. So B is the right answer. So you're finding the force on the particle in a magnetic field. It's a beta particle. So beta particle, which is a negative. So when you're finding a force on a negative particle, so you should use your right hand. So how to use the right hand? Your index finger, your first finger will point in the direction of a magnetic field. South. So in this example, your index finger should point into, like towards the screen. Your index finger should point towards the screen. Your second finger will represent the direction of the particle, which direction the particle is moving. So in this example, the particle is moving towards the right hand side. So your second finger should point towards the right hand side. So index finger is pointing into and second is pointing towards the right hand side. Where your thumb is pointing, that will be the force. So in this example, your thumb will point downward when you apply the rule. So this particle will deflect downward. So in which direction this beam of a beta particle will deflect? It will deflect downward, because the thumb automatically represents the deflection, the direction of the force. Then in question 37, the arrangement shown is used to check whether a floor inside a cardboard packet contain a certain, like is above a certain level. If it is above the level, the floor absorbs the radiation from a source, so that does not reach. Which type of radiation is suitable here? Alpha is not suitable. Why? Alpha can be stopped by a paper, so even there is a floor level up, but alpha won't pass. Gamma also not suitable. Why gamma is not suitable? Because gamma highly penetrating. So even there is a level of a floor, like if a floor level is up or higher than the marker, so there will be radiation as alpha, the gamma radiation cannot be stopped by the paper or a cardboard or a floor. So detector will record. So which is the most suitable source here? Beta is the most suitable because when the level is below, like when this level of the floor is below, beta radiation from the source will come out and passes through. But as the level rises, as the level increases, so what we'll observe because beta cannot pass through this. So as a result, these beta particles, amount of beta will decrease. So we can identify that the level of the floor is above the marker or above the certain level. So the most suitable source which we can use here is a beta source. So B will be the right answer. In question 38, a nucleus of americium, which is 243 and 95, emit alpha to form a nucleus of neptunium. Which equation represent? So remember, whenever there is an alpha decay, atomic mass decreased by 4 and atomic number decreased by 2 and emitting out alpha particle or a helium nuclei. So atomic mass decreased by 4 and atomic number decreases by 2. So it is 243. What is 243 minus 4? So that is equals to 239. And 95 minus 2, so it will become 93. So it matches with option D. Then question 39, a certain element has several isotopes. Which statement about isotope is correct? To be an isotope, they should have same number of proton, but they should have different number of neutron. So they must have different number of electron. That's also wrong. Electron and proton should be same, neutron only different. They should have same number of neutron. That is wrong because they should have different number of neutron. They should have same number of nucleon. That is also wrong. So D is the right one, that they should have the same number of protons. Then a reading is taken every 10 minutes. So after every 10 minutes, we record the reading. Question is, what is the half-life? What is the meaning of half-life? Half-life means time taken by half of the radioactive sample to decay. So if I take 800, what is half of 800? Half of 800 is 400. So how much time 800 become 400 changes to? So it was started with 0 and 20. So it is 20 minutes. So B is the half-life. Same thing. You can take any other value. It's not necessary. So example, you took 400. Reason why I'm taking even numbers, because it is easy to divide them. Or you took 560. What is half of 560? That is 280. So this was 10 become 30. So how much duration? 10 to 30 minutes, 10 minutes to 30 minutes. The duration is actually 20 minutes. So it took 20 minutes to become half of its original value. So that's why B is the right answer.